Welcome back to J Squared Manufacturing Design. Today we're going to talk about the A half or the cavity half of the mold. We're working on the first mold. Very simple mold. Don't worry, we will get into more complex molds. I just wanted to start off with something simple because, well, it's a difficult topic to cover. Um, so now there are just a few things in the cavity of a simple mold you have to watch out for. One is going to be the screw bushing hole. Going to come through the center, we'll call it 2 inches. 2 inches is way too big. What am I doing? 1 inch through the center, and then we'll have our gate locations off of that. So there's a 3/4 and a 1 inch screw bushing, not a 2 inch screw bushing. That would be insane. I'm sure there is a 2 inch screw bushing, but not for normal usage. So now we can put our water in because that's pretty much the only thing that really affects anything. We're going to have our water exiting both sides. We're just going to do 2 circuits again. But I think what we're going to do is we're going to have, let's look at this here again. So I guess it really doesn't matter. Where I put my water. So as long as it comes out the sides. We do that so there's not water coming out the top of the mold. It's kind of a unwritten rule as far as like electronics and stuff like that. You don't want water coming out where you have electronics. That's kind of an obvious rule. And I've heard stories where they had water lines on top of the molds, and the water lines fell down into the mold as it opened and closed, and crushed the water line and had water spewing everywhere. We also heard stories where someone's tried to stop that from happening and got their hand caught in the press, and their hand was completely destroyed. So safety is everything. Let's try to make these mold designs safe. So let us measure here to here, 1/2 inch. So applications, mold cast, water line 0.339. Make datum, offsets, and my picture's in the way. Your value, -1.125. Done. Top, call this the top. These sides. Oh, look at that. We may not have room for water in this block. Now what we're going to do is we're going to run I wonder if we can just run a line that this mold does not require much cooling. It really doesn't need 2 circuits. But since we have 2 circuits on the other side, yeah, let's do this. just because we don't need it. Oh. Oh, and my kids decided to subscribe to my YouTube channel just now, so they're my 8th and 9th subscribers. And I was like, oh, it's useless. Then I realized that's the whole reason why I'm doing this, is to interest younger kids in design and manufacturing. So it's kind of the exact reason why that didn't happen. So my daughter was like, I'm going to learn this and I'll understand it and I'll be smart when I'm older. I was like, that's awesome. You can see let's do this. Let us first change the color of our block. There we go. Now we can see our water lines are a little far away. So let's make them. Now they're probably a little close, but I can live with that. Now we have it in and out. So now we need to add in our waterline fittings. Oh, let's rearrange our tree over here. Okay. Full tapered NPT 1/8. I use a different size hole for NPT sizes are kind of tricky. But on memory, and memory goes sometimes. The mold shop is just gonna go, whatever. I know what he means, and use whatever bit they have. But this is actually a little better because it allows me puts a little more clearance between things, since it's a larger hole in my design. So now let us put in. Let's go ahead and put in the mounting holes. So sketch view, rectangle, construction rectangle. Just like that. Thread the needle on that. There. Oh, should have put dimension on them. 6. 4.875. Oh, whoa. 3.875. That's 6 too far. Let's go with that. Alright, hole. Standard UNC 5/16. We got some clearance there. We got some clearance there. View. Blue. Let's color these water lines so that they're evident, so we know if something hits them, then that's a problem. Okay, now let's go ahead and measure that. I'm curious as to how much space I really have there. 100 thousandths. Nah, it's doable. Especially right there at the terminal end of the drill, there won't be much drifting there. That's what we're really worried about with like clearance from hole to hole is drifting in the drill. Um, as the drill travels deeper into the material, it'll tend to drift either left, right, up, down, and it can be off from straight line. Um, as well as if you get too close, then anything kind of rust, if any rust were to form on this hole, it could bleed between the two holes and you could have a water leak. So 100,000 is going to cause a problem. If we drifted and we had 100,000, then we may have more of a problem. So, okay, now the clearance. So what do we have on the other block? Just want to match that radius. 400 radius. Model round 0.4. Boom, 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 boom. Extrude. Fine. Project. Not project. Offset. Loop. Next. Previous. Accept. Negative 0.005 because the arrow is pointing outward and we want to go inward, so we're making it negative. Now this is a 1.375, so I need to do 875. Flip, remove material, and we got that. Now we need our chamfer. 0.65. And we're good. Now we're ready to put this insert into the mold base as we are the other one. We'll do our runner and our injector pins for those last. So now we go back to our split. See, we have our water and our So next we're going to go to download a mold base because it's easier, and we're not worried about building a custom mold base, so we're going to download a mold base to fit this in, and we're going to go through the process of picking a mold base and getting it downloaded and assembled. So mold base is next.